So the last question that is asked from the subject AOB in test series 4 is from the topic basics of fiber optics and it is for 1 mark. So here the question is a laser beam of 50 milliwatts. So the power of the laser is 50 milliwatts and has an aperture of opening 5 mm. Uses a wavelength of 720 nanometer, has a focal length of 0.1 meter. So with this data we are asked to find what is the intensity of the image that comes out from the laser beam. So we are given with all the quantities, we are asked to find what is the intensity of the laser beam. So we know that intensity of the laser beam, this is a question asked. So intensity is given as power from the laser divided by the aerial spread. So we need to calculate what is the aerial spread of the laser output. So the aerial, we are given with the power which is nothing but 50 milliwatts. So we need to compute the quantity aerial spread which is not given or which is indirectly given. So the aerial spread is given by the relation pi of theta p whole square, where theta is the divergence of the beam which is coming out from the laser, and p is the focal length. So we are given with the focal length, but we need to calculate what is the divergence. So the divergence is given by the relation theta is equal to 1.22 lambda by alpha. So where lambda is the wavelength and alpha is the aperture length. So we are given with all these two quantities. So we can calculate the divergence, which comes out as 175.6 into 10 to the power minus 6. So now we know the divergence, we can calculate the aerial spread, which is nothing but pi of 175.6, which is the divergence calculated here, and where p is the focal length, which is given as 0.1 meters. So the aerial spread after computing comes out as 9.691 into 10 to the power minus 10 meter square. So now we have calculated the aerial spread, and the intensity is nothing but the power output, which is 50 milliwatts. So converting it into watts, 50 into 10 to the power minus 3 watts divided by 9.691 into 10 to the power minus 10 meter square. So it comes out as, so this quantity is meter square. So it comes out as 51.59 megawatt per meter square.